Us Gyan about how to actually back up data and configuration. To you, welcome Justin and Brian. Thank you.
Thank you.
Thank you. So that introduction was a little misleading. We're not actually talking about backups. We're talking about how we draw the line between configuration data and data in the context of configuration management systems. Sorry about that. It's clear.
No problem.
So my name is Brian Horgan. I'm a system administrator at Mozilla. Been there for about a year and a half. Prior to that, I had 12 years of experience in the hosting industry.
I'm Justin Dow. I work with Brian. We work on the same team, just managing the general core infrastructure at Mozilla.
So I want to tell you a little story. This is something that happened to us recently in Mozilla and precipitated this whole exercise of thought. Somebody, who I won't name, checked in a 4 gig ISO file into our repository for our configuration management system. It's not the best idea, but it happened and we had to deal with it. Particularly our low bandwidth locations, such as our location in China, pretty much fell over. It checks out our Puppet repository on a regular basis from SVN, which is what we use.
Like every 10 minutes or so,
Yeah.
this does an SVN up.
That's required to get the data to all of our systems every 10 minutes. And we need to check out the latest Puppet data as often as possible. Like I said, our data center in China is not known for its fast link. I'm not sure what the exact speed was, but it's pretty slow. We have email-based commit reports. Needless to say, they're a little too big. And as a result of this, our Puppet master in China didn't get any updates for a week while we sorted this out.
And aside from just that whole site being kind of non-puppetable, non-managed with configuration management for a week, our sysadmin team, we're actually pretty distributed around the world. We've got someone in Singapore, India, a couple people in Europe, US, Canada. I don't know if there's anybody else anywhere else, but anyway, they're kind of everywhere. And with varying speeds of internet service providers and stuff like that. And so a couple of people who were just trying to do their, they come to work, and since we're using SVN for our configuration management data, you come to work and you do an SVN up just to get up to the latest revision. And then that kind of blocks for a long time while it's downloading 4 gigabytes of data and calculating the diffs and all that, trying to figure out what to do with it. It was actually what seemed like a small issue turned out to be a huge problem. And so we started looking at maybe SVN, Git for that matter too. Any version control system that's really geared for text files is not a good place to be storing your binary data.
That was a catalyst for the separation of data and configuration in our repository. Some data is meant for a version control system. Other data is probably not the best place to put it. So that asks the question, what else doesn't belong in a VCS? We started going through our repository, looking at all types of files we store, and trying to determine the criteria for what does and does not belong. We want to set up some sort of standard where we can go through a repository and evaluate, should this be in the repository or does it need to be somewhere else? And it turns out some data is in the middle. So we tried our best to determine the criteria, and I think we did a pretty good job. So we came up with a few data classifications. We pretty much separated it into configuration data. That can be things like, say, Apache configuration files for MySQL. Can you think of any other examples?
All of our Puppet manifest in general, the configuration logic, it's all text, so that can go in there.
Yeah.
In a versioned way, it's nice.
Keep alive D configuration files. These are all things we can really easily think of. Then we start to look at, well, what makes up configuration data? And pretty much was everything else. And we sort of classify that into the container of application data. Example of that could be RPMs, packages, license files if you have any sort of commercial software. Pretty much anything that is a little too large for a typical VCS. So now we'll get into the actual characteristics of configuration data. It's often human-readable, line-oriented ASCII. Everybody knows this. Sometimes it's stored in some sort of structured format, JSON, INI type format, XML, stuff like that.
YAML.
YAML.
LDIF, spec.
often human writable. Sometimes it's not the best idea to try to write some of these files, but if you have to, you typically can. Typically small file sizes on the order of a few kilobytes. Sometimes they're larger, but most of the time they're pretty small. They're easily compressible.
Yeah.
And hopefully there are comments in these configuration files.
Yes. Comments are the key to everything. Comment your code.
Now we'll look at the characteristics of application data. It can be binary data, let's say RPMs, packages, stuff like that, stuff that's typically not human readable or writable. Say you have images,
Yeah, dumps like, MySQL. Well, actually, the dumps themselves are text readable, so that's okay. I don't know if I'd put that in a VCS though. Seems like a good place for backup software, tape libraries, things of that nature. But yeah, definitely RPMs, deb files, tarballs, ISOs, license files, and pretty much anything else that kind of is not text. That's a good way to put that.
typically machine readable, it's interpreted by some sort of program, not necessarily meant for humans. The opposite of that is machine writable. Some sort of application probably created this data. It's not something that you necessarily wrote. And often they're larger files.
4 gigs even.
Yes.
Exactly.
4 gigs
Yeah,
or
some
more.
terabytes in some cases.
Yes. And this goes for compiled binaries, any kind of code that's compiled.
Sure. Let's say that you're a software company. Who knows any software companies? You have your code, you make builds of this. Sometimes you need to check in your tool chains along with it. That can be a lot of binary blob type data. That's it. Any questions? No, we're just kidding. So just because you can do it doesn't mean that you should do it.
Yeah, when the gentleman checked that, or the person or lady, checked in that 4 gigabyte file into SVN, there was no errors. I mean, it took it. It worked fine from their end. It took a long time, but there was nothing, they didn't know, there was nothing that said, hey, don't do this. So it was just as we were checking it out when we were like, hey, why is this taking forever?
It's healthy to push the limits of technology, within reason, of course. That drives innovation. But just because you can do it doesn't necessarily mean it's, always a good idea. Now, let's take a look into some of our storage options for these different types of data. Version control systems, great for configuration data, plain text files, source code. Geared towards a collaborative environment, you can do diffs, you can track who commits to what, you can see comments, all sorts of metadata about this data that's checked into the repository.
There's usually some kind of blame command so you can see who broke it.
Yes, exactly.
Again, this is not ideal for binaries. It usually works for binaries, but just definitely not a good idea.
Well, there are various extensions for tools like Git and as such that allow you to check in big files to version control systems, but if your data changes rapidly, it's still probably not a very good idea. Your repository is going to get large, and you typically run into some sort of performance problems that you will spend a lot of time trying to optimize. And you have to ask yourself, do you want to invest time in trying to make this work, or should you pursue another avenue of storing this actual data?
Yeah. Sorry, I was going to say, particularly because it's a collaborative environment, anything that you do to this system is going to affect all your coworkers on it too.
Diffs are often not very helpful with binary data. There are some tools that make that a little bit easier, but when was the last time somebody asked you to do a code review for a binary?
Binary diffs?
Performance can suffer. Some systems like Perforce, work a little bit better with that, but still probably not the best thing to do. Is there anything to add?
No, that's all I got.
Replication is often easy, especially with distributed version control systems such as Git. Even if you run something like centralized like SVN, you can typically run read nodes and distribute that and scale it to where it needs to be. File system-based storage is pretty good for binaries and large files. Self-explanatory. Versioning can be hard. You have various file system options like snapshots and sort of checksum trackers and stuff like that where you can track when a file changes. See previous versions of the files. But if you have a distributed file system or really large data sets or data all over the place, it can be sort of hard to put that into a centralized place.
And often the versioning with when you're talking about binaries on file systems, the versioning is done in the file name itself. Unfortunately, that's the, unless you've got something like snapshots and stuff set up, but just for regular, like I've got 2 versions of the same thing, but one's newer than the next. What do? You copy the first one to .org or something, and then you've got the next version in place, you know.
Replication can be hard. This is a solved problem. It's not always hard, but it can be, depending on what your environment is. Sometimes you have to replicate lots and lots of rapidly changing data over high latency links. It's not the easiest thing to do. There are lots of available tools to synchronize data. There are a lot of already solutions out there where people have solved it before. If you have money, you can buy a lot of tools that does this for you. You can buy storage systems, such as NetApp. We use a lot of NetApp at Mozilla. And they're happy to take our money. In exchange, they'll give us a system that works most of the time. But so it's not always that it is hard. It just can be hard.
There's definitely, aside from the commercial tools available, there's definitely some open source tools that can help that we'll talk about a little bit later.
So, giving a practical example of this, we'll go a little bit into how we store the builds for Firefox. We have a lot of commits. I think we average about maybe 5,000 to 6,000 commits per month. That's a lot of data. For every commit that takes place, we have to check out that code on a build machine. For every platform that we support, we compile it, make sure that it compiles, log any compiler warnings or errors, and then we take that resulting executable and we run it through a number of automated test systems. Those test systems will see if we have any bug regressions, any performance problems that were introduced. There's a whole lot of stuff. Maybe you want to add?
Yeah, they do, I think the build infrastructure as of right now is probably a few thousand machines. Running, I think, 8 different operating systems, and this doesn't include the phones. We're also running multiple Android phones and whatever the Firefox OS phones are to basically, and each for the phones, I think they cross-compile the binaries, but then they have to test them on actual hardware. So we have 8 operating systems. I think a couple, 3 or 4 different versions of Windows, 32, 64, Linux, Mac. All that kind of stuff. So every time a developer checks in code, and this isn't necessarily just to the main repository. We have like what's called a try repository, so someone can check something in without it merging directly into the product. But even then, they check something in just to try out their patch or their change. It's going to get checked out basically 10 times, compiled 10 different times, and tested rigorously 10 different times for every single check-in. And that's a pretty high performance system, given that, like you said, in December alone we had 5,300 something check-ins, and these kind of go around the clock because we have contributors all over the world. But once you've checked in your code and the CI system has done its thing, the developers often want that resulting binary back, not to mention it needs to get tested by all these machines too. And so that needs to get stored somewhere. And the last place you want to do is have 5,000 builds of Firefox get put back into Mercurial every month. So for that we have ftp.mozilla.org.
So it's also really important to note that as a developer, when you make a commit, you want to know how it is. It's important that you get feedback for all the platforms as quickly as possible. So performance issues are really a critical part of this. We can't tolerate any sort of lag. We have a typical expectation of about 15 minutes for this to be built and these results to be uploaded where a developer can see the results of his commit. As we grow, we have to deal with scaling all of this particular data. This generates a lot of data. Each Firefox build is quite large.
Like 15, 25 megabytes, something like that.
Exactly. Anything else you would like to add?
No, I think that's the...
Something else that complicates this environment is the unavailability of maintenance windows. Anytime we identify some sort of performance issue or deficiency with this particular system, nobody wants to stop development of Mozilla products. It's particularly difficult to get everybody to agree to take everything down, even for critical maintenance. And that has led to some other complications, and that was probably the primary driver of why we never started storing these build devices, or these build files, in Mercurial.
Yeah, like I said, the Firefox development happens around the clock, around the world. There's, I don't know the number of contributors currently, but there's 10-minute downtime is going to basically block somebody from doing their job.
Okay, both public contributors and paid staff, so it's very expensive to have a maintenance window. And even on holidays, it may not be a holiday in Australia, and it's a holiday for us in the United States. So there's a lot of global issues that we have to deal with.
We don't get Sundays or anything.
So this is just a little bit about how this workflow works. Once a developer makes a commit, build boss check out the code, build it, run all the automated tests. As we mentioned, the resulting binaries and test data is uploaded to ftp.mozilla.org. And this is all public. You can go and see what other developers have committed in the results of this build information. We don't bother to version these builds outside of regular file system snapshots. The way that we identify these builds uniquely is just by the file name. We create a directory in our try builds that has the email address of the contributor and then the actual tag of their commit. So it's nice to track these, but we don't need to particularly pay attention to how these are versioned. The underlying storage system is actually quite a significant system. We depend on NetApp for this storage structure, and we use snapshots quite heavily, and if we need to go back in time and see some sort of particular data, that's how we would actually access it.
And I believe there's actually 2 NetApp stacks with multiple heads that can fail over to each other as well. It's a pretty critical system. We can't really afford downtime on it.
So I guess now we'll go into some examples of how you can reference external data sources using configuration management. Do you want to?
Yeah, so now that we've established that there's basically these 2 types of data, and you want to separate, you really don't want to put your binary stuff in your VCS system, whereas your configuration data, your management tools or whatever, like Puppet or Chef or whatever you're using, might be relying on having data available to it. And so in a way, you've got to find a way to tie these back together. So if I've got my binary blobs here on one server and I've got my configuration data here, my essentially, like in the sense of Puppet, you have masters and clients. The master doesn't really want to have that data on its hard drive, but the resulting Puppet client does need it. So there's a couple different ways to do that within Puppet. For instance, we're going to show some examples of how to do it with Puppet. I'm sure all the other config management tools out there have a way of doing this. And I guess we'll go to the space bar. So for instance, in Puppet there's a VCS repo type that will do exactly what you want for gaining data from another VCS repo, which is kind of neat because a lot of, we actually use this because of a lot of our web applications. It's all stuff that's stored on GitHub, and to deploy it to a server, you don't really want to take the same application code, pull it down from GitHub, and then check it back into our private SVN repository and push it out that way. Because even though it is, in this case, all text files and human readable, it's just a lot of data. We have a lot of websites, and there's quite a bit of code there. Plus, you don't want to be storing the same thing in 2 different locations because you end up with drift and stuff like that.
Yeah, I think it would be important to know that this particular Puppet code is useful for pulling data from a VCS other than where you store your actual Puppet data. Because otherwise you could use built-in handlers within Puppet to handle it. I mean, they've solved this problem. You can recursively apply files from the VCS where this code happens to be stored. But if you have a different type of VCS provider, like in our case we use SVN for our Puppet code, and we have code in Git. We have SVN externals, but it doesn't really work too well with Git. You can use other submodules if you have the same systems, but that's not always practical. So this will actually be pulled into a directory from that actual source on GitHub.
That's a very useful tool. And then the other, when you're not talking about a VCS repo, when you're actually talking about binary data, like so my configuration management tool says this server needs to have these binary files in this path. That gets difficult to do because then at some point you're basically using external tools. I mean, you can do a couple different things. You can use, you can either put these binaries into a package and let the package managers deal with them, or you can basically write scripts that do wget, curl, rsync, lsync, whatever to sync your data from another location, and But when you do something like that with rsync or wget, like say I've got my file on a server, and I want to be able to, it's a tarball, and so I've got my Puppet code all set up to like wget that tarball, untar it, and then install my application that way. That works fine, but versioning gets really hard. Now if I want to update this tool, I need to either make sure that I've put a version number in the file name, and then reference that version number in the code, or you can just have it every single time it runs, download it again and untar it again, and just knowing that eventually there's going to be a new version and it's just going to auto-update. But really, these are hard. Is there another slide on?
Yeah, so I guess what he's driving at, it's difficult to trigger intelligent updates of this code. And just because you can do it doesn't mean it's necessarily a good idea. We used methods like that in the very beginning, and it worked for a little while. And as we grew and got bigger, we eventually moved away from those types of systems. It's just not necessarily, very practical. Some limitations of using rsync to distribute data is that you often need a single source of truth, unless, of course, the underlying file system is sort of replicated or distributed or something that already solves that problem. If you have servers all over the world and you want to be able to upload data to like an arbitrary server, it gets a little bit harder. There are tools such as csync2 and lsync which handle that. You can upload a particular piece of code to any server and it will automatically replicate that to all the other systems. But it does have some limitations. If you have some sort of split brain system or some sort of collision, usually the reconciliation algorithms for these are fairly primitive, and that requires your attention to go and manually make a judgment of what should be there and what shouldn't. And with binary data, it's kind of hard to diff it and merge, so it can get a little complicated.
Yeah. I think what we're trying to say is that really the best way to do it is to use your package managers for binary data distribution, even though it doesn't often seem like the right way. If I've got one single binary file and it just needs to go on a server, it's not really part of a software application or anything. I think it's still valid to use RPM or deb or something and store it that way. That way you've got a version number and you've got your Puppet or configuration management tools can actually reference it using the package type and stuff like that. You can get better versioning and rollbacks and stuff like that.
You can store different types of metadata in, like, say, the package name in various fields. If you need some sort of little tag, you can exploit that to store those little data bits in the actual package. Distributed file systems. You can use Gluster, Lustre, all sorts of solutions out there that have already solved this, but sometimes they can be hard. Sometimes performance can be a little bit difficult. You need a minimum number of machines. It's only appropriate for a certain average file size, or archiving backups. There's all sorts of complications, and you may not need a complicated solution. You just may need to have a simple problem that you need a simple solution to, and you don't want to go through all the extra effort of being an expert in the distributed file system, because when there's a problem with your file system, it's usually a pretty big deal.
No, that's it.
Of course, NFS. We all love NFS.
I think everybody says, hey, you can just solve this with NFS, right? Because you can solve anything with NFS. Why not? But then you have two problems, right? We don't like using NFS as a way to distribute files. I've heard a lot of other, when I think back about looking into like how to scale my Puppet configuration management tool. I keep going back to that because that's a lot of what I do. But I've read online some other companies they're saying go masterless. Don't use a Puppet master. Instead, just distribute all your Puppet manifest to all the servers via NFS. And then I think about like my infrastructure and what that would look like, because I've got what do we have, about 6 data centers total all around the world, 11 different offices, and how would I don't want to mount one NFS share on all my 1,400 servers across the world. That doesn't seem like a good idea, right? So I think NFS definitely has its place in our environment. Even we use it extensively. Distributing files is definitely not the right way, not the right thing to use it for. At least in the sense of this talk here.
Although we do admit that we use NFS as a backend storage for ftp.mozilla.org. We have a NetApp, and all the front-end nodes pull everything off the NetApp using NFS. It works pretty well for the most part, but it's not always the best tool for the job.
Yeah, but if I need to get that same data to a different data center, I'm not going to mount that same NFS across the internet. not the way. That's not how we do it.
It-
And I would use LSync or something like that.
Exactly. It works better for like large files. If you have a bunch of really tiny files, I mean, all the get attribute requests and everything, pretty much slow everything down. You really need a lot of IOPS on the back end to make that even marginally acceptable in terms of performance.
Yeah.
So now we'll just go into some tools that may work for you. There was a talk earlier, I believe, I don't remember what lecture hall, but a gentleman who wrote Git Annex gave a talk on that. And it's a pretty interesting piece of software. It allows you to manage files with Git without actually checking them into Git. It's useful when dealing with files that are larger than Git can currently handle, whether it's due to limitations with memory, time, disk space. It's an interesting sort of solution. I guess it's an analog to like Dropbox.
Yeah. It essentially stores your versions of your metadata, but not the data. Is that correct? Or?
I believe so. There's also another piece of software called Git Media. It's based on the same principle. I believe it's a little older. I'm not sure the development activity of that, but you know, it's another option for you if you need it. Git attributes is really cool. It allows you to diff plain text portions of binary data that's checked into Git. So for example, you can have a PDF, and if you want to version these PDFs, you can configure it such where it would actually only look at the actual text contained within the PDF and give you diff reports on that and not all the other binary data and formatting information that you don't necessarily care about. It also works on images, like EXIF data. You can do diffs on that. I think that's what GitHub uses to version control images. You know, just because it works doesn't mean it's always the best idea.
That's a good idea.
Okay. Do you want to go into
No,
some issues we have with our VCS?
I don't think so. I think we'll probably end a little early.
Bohr is also pretty neat. It's a binary versioning system. It's sort of like a poor man's file system snapshot. I think it was originally designed as a desktop tool to help you manage like your photos and stuff like that, but it has its place managing data on servers. It allows you to version control these binary blobs and track changes and updates to, I guess, this binary data.
So none of these, we haven't actually used any of these extensively yet. They're all things that we've started looking at a little bit. We wanted to put them out there to see if the community at large is using any of them.
Yeah, once we determined the need to separate configuration and data, that got us thinking about how we can effectively store this. But we're still working on solving this problem. This is not something that we've mastered. We're sort of thinking out loud with this talk, and you know, internally we're collaborating about this problem, and we have a number of situations where we need to solve this problem, and the same tool is not always the right tool for the job. Mm-hmm. Sometimes one tool may work in one area and has limitations or some sort of overhead where it may not be the appropriate choice for the same problem with a different data set.
Mm-hmm. Is that it?
I believe so.
And
Well, I think we went through this a little too fast, but we have the slides up online if you'd like to see. Anybody have any questions?
Hi, you recommended using package management to distribute some types of binaries. Do you run into difficulty when you're trying to distribute binaries to a bunch of different distros?
Yeah, that's another problem that we are constantly trying to solve. It's actually, we actually have an in-house tool that we're developing as we speak to deal with just that. And there's, I mean, some of the like easy ways to deal with that is there's a couple of tools out there on GitHub, like FPM, the package manager. It can deal with basically you feed it any kind of package and it can output any other type of package. That's probably the easiest way just to get rolling, because a lot of these times when you're just really trying to distribute something, it doesn't necessarily mean it need to be like the Apache software package or something like that. It's just you need to get it out there, but it's what basically we're really trying to avoid is ever have like a bunch of sysadmins have all the files they need to do their job on their laptop, and then like you've got your files, he's got his files, we all download from the internet somewhere, and then we need to update that one file, and no one knows like where it came from or anything like that. So we're really trying to get everything to be centralized and kind of abstracted away from the sysadmin, and more so that the ecosystem as a whole can work. And so yeah, so when you need to version something, like package managers are really good at that. You can also set dependencies, and you can do cool things with them.
And it's probably a problem that you've already solved. I mean, I'm sure most of us have packages that we maintain for our infrastructure, and we have a way of distributing and tracking these to various systems. And we can leverage that and to solve that problem with this existing infrastructure without having to create some sort of new system. Any other questions?
All right. Then I guess we should go to lunch a little early.
Thank you very much, Brian and Justin.
Thank you.